All right, hi everyone, welcome to the container orchestration talk. So the original title was container orchestration, but then we realized we wanted to broaden the scope a little bit, so it still says container, but with a little line on it there. So we would cover container orchestration as well with Kubernetes, and also more general types of, orchestrations as well. So I'm Arthur Berezin, Director of Product for Cloudify, and today I have Trammell with me.
Trammell.
You want to introduce yourself?
I'm Trammell. I'm a product expert at Cloudify.
Perfect. So, us being Gigaspaces and working a lot in the orchestration space, seeing a lot of orchestration platforms, obviously working on a container orchestration platform for a while now. So we've decided to take several orchestration platforms and do a little comparison. We've tried to be not biased and try to be neutral to the container orchestration, to the orchestration platforms out there. Today's talk, we're going to do a little, orchestration 101. What is orchestration? What would it involve to work with an orchestration platform? And then we made a little comparison between the several platforms out there. We've noticed there are a lot of different platforms and taking different approaches to orchestration. And then doing the actual comparison between the different types of tools we wanted to compare here. So, what is orchestration? And that's an open question to you guys. So, anyone wants to give it a shot? With their hands up. All right, a different question. Who has ever written a hot template? All right, a few hands. Who ever worked with Kubernetes recently? A few other hands. So, anyone would like to make a suggestion to a title? What is orchestration?
Usually they work inside the node or inside the container. Orchestration work on the level of building blocks like VMs, containers, anything like this. So it manages resources and connect them and change properties of the resources. Usually has some based on the building blocks.
Right. So it does involve, so definitely agree to that statement. So it does involve taking several resources and essentially orchestrating them, not only from within the virtual machine, for example, as the configuration management tools do, but also combine the wider picture of managing several types of resources and having a template that describing this whole environment. So essentially, we do see, obviously OpenStack is one great example of developing great set of APIs to manage different kinds of resources. So we can manage VMs, now we can manage networks, create ports, define even quality of service for networks. A lot of SDN platforms out there and SDN controllers that are being defined by APIs, etc. So, in the past 5 to 10 years or so, we're in this dawn of APIs. So every single platform that is being out there, that's being released, comes out with a set of APIs. And essentially what orchestration does, it allows you to model and to configure and to manage the lifecycle of all of these APIs and joining them together in a single point of view. I would say application point of view, but that would be a biased statement. But in a single point of view where you can take several resources, put them together, and even combine several types of platforms in a single blueprint, so you can mix and match technologies. So usually, the common characters of an orchestration platform is that you would have some sort of a descriptive language that would describe the resources that you manage as part of the orchestration, as part of the application that you're trying to bring up. You would have that as part of a blueprint or a template or a script or a configuration file that would join several types together and basically describe the scenario you're trying to bring up. So it wouldn't be prescriptive. It wouldn't say go to this machine, connect to that machine, and run this specific operation. Rather, it would define what you want, what the outcome you would like to be. So, for example, you define the specific application, and then the orchestration platform would figure it out what API calls it need to make in order to bring that environment. All right, so I was talking about what would it make to bring up an orchestration platform, and essentially most orchestration platforms would require having some sort of a descriptive language describing the application. You build a blueprint, or you build a template that you use to run the orchestration, and orchestration platform would take that template with a set of inputs in order to bring up that application. And the orchestrator itself, the orchestration platform itself, is responsible for passing context from objects in order to bring up the application that you're describing. And one example, and a classical example for that would be to bring up, for example, a database, and then use the same context, for example, the IP address from that database, and pass it to the different application server that will connect to that and use that database. So what we've realized as part of this, as part of preparing for this presentation, is that there are several types of orchestration platforms. There's the type of the application-centric platform, where the orchestrator orchestrator's point of view is on the application and defining the application, describing the topology of the application. There's the infrastructure-centric orchestration platforms. OpenStack Heat is one of them. Amazon AWS is another example of them, where that orchestration platform is focusing solely on orchestrating resources from a specific IaaS. And there's the set of the type orchestrator that focuses on containers, and Kubernetes being an example for such a platform. So part of the comparison preparing for this presentation, we set a specific example that I would be showing you now. So this is the test example that we were trying to bring up, and essentially we took, we were trying to build this application in several types of orchestrator, essentially doing a comparison between the dialects of each orchestration platform. So as part of this test application, we set up a set of Node.js application with sharded Mongo database. At the lower bottom of the screen, you could see the MongoDB database clusters that we use, and Mongo configuration servers for the shards. So the requirements for the orchestration platforms, and again, we were trying to be non-biased toward any orchestration platform there. So the requirements for the orchestration platform would be, first of all, to manage the dependencies between the multiple components of the environment we're trying to bring up. For it to be reproducible, meaning we could take the same application blueprint and deploy it multiple times on multiple types of environments, and hoping to get the same result. Clonable, recoverable, meaning if some component fails, I need to have some sort of ability to recover from that state. And upgradable, right? So taking care of the day 2 problem, where we want to upgrade some portions of the application, maybe want to configure a new, deploy a new application tier, maybe want to upgrade some portions of that tier, etc. So dealing with day 2 is also part of the things we were trying to tackle with auto healing, manual healing, etc.
Okay, so I will cover a number of tools, well, just 3. The first 2 are pure play orchestration. That means that they try to cover basically everything. And the first one is Terraform. So Terraform is a tool, it's a command line tool created by HashiCorp. It's part of a group of tools that HashiCorp has developed together. They're mostly free and open source. There is a commercial tool called Atlas that ties all the other tools together. But I will not cover Atlas or any of the other tools because, well, this is strictly about the orchestration part of Terraform. It is a very simple and easy to use tool. You can get started with it pretty quickly. And any features that it doesn't have, you can generally try to extend with plugins. Yeah. So, like you said, like Arthur said, you can have like a configuration file which describes everything that you want to do with Terraform, and anything that Terraform doesn't. So Terraform is strictly related to infrastructure, but anything that is not related to infrastructure, you can try to do with external scripts and modules. This is a very simplified version of deploying a compute node, which is just a VM. You can see that I described the number of VMs to deploy. I can use variables I can use like a variable to sort of providing inputs at the beginning of the deployment. I can reference properties of other resources. So like this network ID, I've hidden it, but there's getting the IP of a floating IP that I already created. And then there's something called a provisioner, which enables me to run a script either locally or remotely on the virtual machine as part of its execution. So that could be, in this case, it's just a script that installs Mongo and starts it. So in terms of other the application side of the orchestration, the first option is what I did in the previous example, which is using a provisioner. The other approach is to combine using console or surf in order to do these are part of the HashiCorp ecosystem. And so it includes tools like console and chef. Other things that I might want to do later that Terraform does not do is auto scaling. So because it's something that you write the configuration and you run once, there's no really auto scaling built in. Maybe you can use console or chef, but you can also use something completely external like AWS auto scaling. Just some pros and cons of Terraform. I'll go over the cons to make it sound bad first and then good later. So it's terrible because configurations are not portable across clouds. It's terrible because it outsources the advanced configuration like auto scaling to other tools. And it's terrible because there's not really a context for managing things behind the scenes. But it's amazing because it's so simple. Really, 5 minutes, you're going. It's really super good with OpenStack. It's got very solid built-in OpenStack support. It's pretty neutral to other IaaSes. So say you want to use it with AWS or you want to use it with VMware, you can pretty much develop any plugin to support another provider. You can look at the plan while, before you deploy it, before you run the scripts and before you run the whole configuration, you can see what it's going to do in case, maybe you already ran it once and there's already existing nodes, then you can do that and see which ones aren't going to be created. It's idempotent, so this is really great. If it fails, you just have to fix the scripts that failed and then run it again. You don't have to undo it first to make sure that things weren't provisioned, get provisioned and stuff like that. And it's also part of HashiCorp, which is a really terrific company. Cloudify is based on Tosca. It's the company that I work for. Cloudify is a bit different from Terraform in that it tries to cover everything, not just the infrastructure and not just the describing the stack, but it also tries to take care of what happens after you deploy, the auto scaling and things like that. It enables you to create workflows and manage workloads against different that are part of the lifecycle of the application. It's very abstract, and because of that, it's very complex, but it's also very, very powerful. What is Tosca? Cloudify uses Tosca. It's a standard for cloud orchestration. Basically, it's a way of mapping your application requirements to your infrastructure's capabilities. So say you have, well, that's pretty obvious and self-explanatory, so I won't really go into that because we're short on time. This is what Cloudify looks like. It's basically a stack of open source tools. Just like OpenStack, just like many of the other tools today, Cloudify pretty much only uses OpenStack things such as InfluxDB, Riemann, Elasticsearch. All of our plugins, all of our code is open source, and you can tie it in with any other tool. So basically, the code is there for you to use. If you want to write a plugin for you, if there's a feature that we don't already support, you can take care of that yourself, or you can find somebody else to do it. Just like Terraform, it comes with everything is put into a single configuration file. Just like Terraform, you provide the install scripts, you provide any plugins that you want to use to provision stuff. But it also enables, you are also able to describe inside the configuration file, the blueprint, anything that is going to happen later on. So say you need to describe like an upgrade process, or you need to describe like a sleeping process or something like that. You can write these workflows into your blueprints and they're part of your application. And also in the next version, you're going to be able to update your blueprint in the middle of a deployment and apply those changes. So that's pretty awesome. Also, it manages the relationships between nodes. So for example, say you have like an IP address in a virtual machine and you need to like scale this to like one IP address in many virtual machines or many IP addresses in many virtual machines. It's got logic for handling these types of scenarios as well. So this is a very, very, very scaled down, salesy type of demonstration of what a node template or a node would look like inside of here. So basically, yeah, it shows you the node and relationships describe any other nodes. And this is using a container. And this shows how you might add like monitoring to a virtual machine. Okay, so one of the things that distinguishes Cloudify is that it has a manager, which means that the manager is trying to stay aware of the nodes that it's managing state at any point in time. So like it's trying to see if one is happy or sad, maybe it's dead, maybe there's not enough of one. It's always monitoring and collecting logs from its agents that are running. Good. Okay, so again, like you get the idea. Like I really don't want to go deep into this kind of stuff because it's like, yeah, you're managing a bunch of different workflows. Uninstall, install, scale, heal, any other custom things that you want to write. So again, I'll do the comparison. Anybody who works with me can close their ears. Why is Cloudify terrible? Well, it's terrible because it is quite complex. There is a delay in the full support of Tosca, so because Tosca is constantly changing, it is hard to hard to keep up with the changes in the Tosca spec. And there's also not a lot of implementations right now for people to borrow examples from. But it's amazing because it's very neutral to the infrastructure and the framework that you're working with. I really can't imagine an application that Cloudify could not tie into. And I know it pretty well, so take my word for it. It's got complete lifecycle management, so like anything that might happen between the birth of your application to its fruitful life and ultimate demise is contained inside of Cloudify's feature set. It also handles both infrastructure and software very well, so it treats infrastructure and software in exactly the same way. So you're able to think about your infrastructure as software, which is really convenient for cloud and OpenStack since that's pretty much what it's all about. It has a lot of post-deployment handling, so it's always staying aware of your application even after you've first installed it. And it can be tied to any peripheral system. So like I said, that goes into a lot of the other things. It basically treats everything the same. Okay, Kubernetes. Kubernetes is quite different from Cloudify and Terraform because it's strictly related to containers, but it does have some like infrastructure related like capabilities. At least you can extend it to do that. but they focus all of their development on containers. And just as a side note, like this is sort of like what I would consider the ultimate message of what I'm trying to give you here, is that Terraform very focused on infrastructure, Kubernetes very focused on containers, and Cloudify very focused on trying to do everything for you. Buy it, no. Container deployment management. So basically, this is a bunch of this is the jargon: pods, replication controllers. Basically, these are the things that how you manage applications using Kubernetes. You group containers that work together into pods. Replication controllers handle making sure that the pods are always staying alive. Networking, how pods are networked together, and there's a lot of exciting things happening with networking today. And services manages just the endpoint. So there's a built-in load balancer for every single service or every single pod. Okay, so this is kind of like a ultimately dumbed down version of the Kubernetes architecture. There's basically a master and a minion or a node. Okay, so like all other tools that we have talked about earlier, there's a single configuration file. Actually, I take that back. This I should have added. There are many configuration files, but you can have one. Let's see. So since it is a lot like Cloudify in that it has a manager that is managing the relationships between pods, it's managing the workflows, it's making sure everything is scheduled in the right way. So this is like more of like a central deployment system, like Cloudify is. It's not like a, run it and forget it like Terraform. Okay. So the formatting here got a little messed up, but this is what you might imagine a configuration file looking like in Kubernetes. There is it's quite similar to Cloudify because it is YAML, and you can kind of understand it by looking at what it's talking about. It's talking about the container that you want to, the image you want to download using Docker and the container you want to run. Okay, so what are the cons? So it's terrible because there's not a lot of infrastructure focus. However, again, you can write a plugin for Kubernetes that will handle other infrastructure. It's terrible because it's really got a pretty limited support for OpenStack, except for rack space. They do support rack space. And there's no topology awareness, so it's not really like trying to manage the entire application from a number of from the nodes that is handling and stuff like that between pods. And it's also you think Cloudify is complex, Kubernetes is really, really complex. It's very hard to get it running. Okay, but it's incredible because it auto heals things like you don't even know how it's happening. It's just like that. It's got an out-of-the-box load balancer, like I said already. Its scaling is very easy to use. The way you want to think about scaling and the way scaling is implemented in Kubernetes, that's how it happens. And then advanced behaviors are very quite simple to implement. This might seem to contradict what I said here about complex setup, but setup is one thing, usage is later, and I would say that its usage is easy, but its setup is quite complex. And with that, I'll pass on to Arthur to handle Heat.
Thank you. So Heat, in contrast to Kubernetes, is very much infrastructure-centric. Essentially, Heat is the native orchestration solution that is built in with OpenStack, and essentially orchestrating the various OpenStack resources. So if we look at the architecture of Heat, you have the orchestration engine with an API talking through a message bus. And the important thing here is that essentially the Heat engine itself also talks with the various OpenStack APIs. So essentially everything that you would need to orchestrate first needs to be implemented as part of the OpenStack APIs, and then Heat itself needs to implement the resources to orchestrate as part of Heat itself. So again, we took the simple use case of taking a resource group, defining, modeling the resource group, then modeling the Mongo shard, and using several apply several configurations into the nodes, then set as inputs the number of instances we want for each component. So for example, if we want, we want 10 Node.js instances, we just set that as an input, run the orchestration, essentially orchestrate the hot template, and get 10 Node.js instances, and the output of that would be the endpoint of the application itself, being the endpoint of the Node.js application. So as an example of the dialect of heat, so I define I can define the various resources needed for the infrastructure. For example, security group with all its properties. I can define the Nova server as the MongoDB host here with its properties. I can have images. I can have specifying a specific image, or I can set for the image to be a parameter. I can provide as an input, etc. So all of the dialect is pretty much rich. And again, example of resource grouping definition, and also an example of integrating it with the Chef plugin to do the configuration management within the instances themselves. One small side note: this is not yet upstream, work done by Rackspace, and I'm not sure if it's ever going to get in, but still, you can essentially write these kinds of plugins and extend the resources that Heat supports. So I'm going to do the Trammell style of pros and cons. So why Heat is terrible? Because first of all, it's very much OpenStack oriented, and most of the focus of the resources that Heat natively supports are OpenStack resources. You can run scripts or execute scripts and configuration files, but these would be external. You don't have a built-in workflow mechanism. Obviously, you want to have custom or predefined workflows. You need to interact with your application. So for example, you would want a workflow to heal some subset of the application, or do some operations as part of the application. So there is no built-in mechanism to do that other than defining the actual application itself. And the post-deployment is very much limited. As I mentioned, there's no set of extensions or plugins that are native that allow Heat support natively. For example, Puppet, Chef, or integration with any custom subsystem that you have in your own environment and you want to be part of the application definition. And the solution for that would be to write custom scripts, which would make the template way more complex. So what are the pros? Heat is native to OpenStack. Essentially one of the main core projects of OpenStack since early on, meaning it supports almost all of the resources that OpenStack provides. But saying that most Heat themselves need to follow the new APIs that they present. So, having said that, and having run rather quickly through the various orchestration platforms, what is the right tool for me, and how do I choose the orchestration platform I need? So the first question I would ask myself, where is my focus at? Do I focus on containers? Do I focus on infrastructure? What is my actual needs for my application? Do I want to define the application and tag in several technologies? Am I running my application only on containers, for example? And I use OpenStack to run the container framework, for example. Do I need support for legacy frameworks? Do I have VMware, for example, in my environment? I want to be part as the application. So, for example, I could define, the web tier running on OpenStack, but the backend of the application, the Java-centric backend application, running on VMware, which is a classic example for that. Do I have heterogeneous environments with different kinds of technologies? So I have a huge set of questions, and the best way to pick and choose the right tool is basically looking at what are my needs and where is my focus and which infrastructure do I support. And the cool part about it is that they're essentially not mutually exclusive. It means I can run, for example, Kubernetes on top of OpenStack, and I can integrate the various solutions, and Cloudify is another example that you could have several components as such, and essentially orchestrating them in a single application blueprint. And Sharon is signaling me that I'm done.
No Q&A after. Take it
All right. So we're done. Thank you.